G'day and welcome back to our Algebra series. This one is going to be all about direct and indirect proportion. Now when we talk about these things, we're talking about how one variable in our equation on a graph works against another variable on in the equation on the graph. So it's the y and the x. How are they reacting to each other? Are they going at the same rate? Are they going at a inverse rate? So this is what we're going to look at today. Now we're going to start with direct proportion, so directly proportional variables. Alright, so this is where we have both variables changing together. So both variables change together. So if one goes up, the other goes up. One goes up, the other goes up. So essentially it's how this is going to change at a constant rate. So it's how it changes at a constant rate. Okay, so we're looking at things going up at the same distance, so each step is the same. Now to be able to get this, we do have to have a straight line. So the graph has to be a straight line. And it has to go through the origin. So it has to go through the origin. Now, what we mean by that is it needs to go through this little bit down here. So it has to go through 0, 0. So the form of this line is y equals mx. There's no y-intercept because it's 0. So we don't have to include it in there. But when we're talking about it in terms of proportionality, so for proportionality, or for when we're talking about proportion, we have a slightly different way of looking at it. We use the letter K to actually represent that constant. And this will come up again and again. So for this proportion, we're going to use that letter K. So now the form is going to be y equals k x instead. So that K is the constant of proportion or variation. It's also the gradient or the rate of change. So the K represents the constant of proportion or variation, sometimes it gets called, as well as gradient or the rate of change. Okay, so that's where that K comes into it, and we're going to be using K in a lot of different ways as we're moving through algebra in the years to come. Now if we want to look at inversely proportional variables, inverse proportionality, so here we have inverse. So this is where it's going the other way. So for this one, instead of when one goes up, the other goes up, this time when x goes up, y goes down because it's inverse. So it's the opposite. Okay, so this one is when x increases or goes up, y decreases or goes down. And we still use that same idea of the y equals kx. We're just using slightly different numbers. Okay, and you can see here in this graph, right, x is increasing that way, and y is decreasing this way. Okay, so for direct, it's going up at the same. For inverse, we are going, one is going up while one is going down. Okay. Now, in terms of this, we sometimes look at things like changing rates. We do change rates occasionally with this one. So I've just got a couple of little dot points to write down about changing rates. All right, so when we do this, we want to take each of the units, or we can use each of the units, and they can be changed depending on need. For example, we might go from dollars to cents. We might go from kilometers to meters, liters to milliliters, etc. Okay, so we're looking at this changing of the units to change not the value of what we're dealing with, but the actual size of the number. All right, and then we can find the value of 1 unit, okay, or of the rate at 1 unit, I should say. The rate per, because we use that word per. Okay, so let's have a look at this in action. All right, we'll dive in head first into a couple of examples. All right, here's our first one. We've got a length measured in centimeters being directly proportional to that length in inches. So this is where we're looking at that proportion idea. Okay, so this is for proportion. We've got a length measured in centimeters, directly proportional to its length in inches. So centimeters to inches, it's making a conversion. We want 15 inches to go to centimeters. So inches is down here. So I'm just going to find that 15, which is right here. And you can see that red dot there already. I go up to the line, then I come across from the line, and you can see in there that it hits that number just below the 40, and it's going up by 2's in there, so it's going to be 38 centimeters in there. So that means our answer is 38 centimeters. All right. The second one there is 68 centimeters to inches. So we can go the opposite way. We've got centimeters along the side here. So it's the vertical line. And I go up to where it says 68. So that's a bit in here. So there's our 68 right there. And I go along the horizontal until I hit that line. Then I come down. And I hit that spot there, which is 27 inches. Probably haven't written that word very clearly, so let's rewrite that word. 27 inches. So my answer here is 27 inches. So this is one of the ways that we can use our skills in terms of graphing and understanding how graphing works and how proportion works in order to be able to do conversions like this. This can happen in terms of money, in finance and things like that, which makes life a little bit easier for us sometimes. Alrighty, moving on to a converting rates question. We're going to convert the following rates to the units in the brackets. Our first one here is $12 per hour, and we want that in cents per minute. So let's convert $12 to cents. So to do that, we need to multiply it by 100 to get the amount of cents, because that's what cent means. And then the hour, we're going to times by 60, because that's how many minutes there are in an hour. So we end up with 1200 cents per 60 minutes. Now the easiest way to work around this one, and I might put it in a different spot to make it a bit easier to see. $1,200 per 60 minutes. I now want to find out what it is per 1 minute. So that second unit in those brackets is almost always going to be the 1 unit that you're looking for. So I want to go down and I want to divide by 60. So I want to get to 1. So 60 divided by 60 will give me the 1. So that'll be the 1 minute. And then I need to divide the other side by 60 as well. And dividing the other side by 60, that's 1200 divided by 6. And let's just see that in the calculator. So there's our calculator. And we want to go 1200 divided by 60. We get equals 20. So this is going to be 20. Just move that again. So it's 20 cents per 1 minute. So it's 20 cents per minute. So there's our answer. Let's look at the next one along the page now. We've got 7.2 litres per hour, and we want to change that to millilitres per hour, or per second rather. So we're going to have to do a couple of little things to change to millilitres. We're going to have to multiply this guy by 1,000, because that's how many millilitres there are in a litre. And then this guy needs to be times by 60 to get the minutes, and then by 60 again to get seconds. So when we do that, we end up with 7,200 or 7,200 millilitres, all right, per 3,600 seconds. And then all we want to do is we want to find what 1 second worth is equal. So we're going to divide by 3,600. And I'm hoping you've seen a little bit of a pattern where we're dividing by that second number. So 7,200 divided by 3,600, that is 2 millilitres. 3,600 divided by 3,600, well, that's 1 second. And then we can write it as 2 millilitres per second. Fairly straightforward so far. Here's our next one. We've got 90 kilometres per hour. We want to do that in minutes per second. So again, we want to, or meters per second, sorry. This guy needs to be times by 1,000 because that's how many meters there are in a kilometer. And this guy by 60 and then 60 again, just like the question before. So I'll do that. 90 times 1,000, well, that's 90,000. And that's meters. All right, and then we saw before that that's 3,600 seconds. Same process, divide by that second number to get the single unit. All right, obviously that's going to be 1 second as we saw before. And then 90,000 divided by 3,600. Well, that comes out to be 25. But let's just have a look at that in the calculator. So I've still got my other one there. All right, so we go 90,000. There's 90,000, and then I want to divide that by 3,600, and we get 25. So that's 25 meters for every 1 second. So we can write it a little bit better than that. 25 meters per second. All right. Last one there, we've got 300 grams per month. This one's going to be a little bit different in terms of how we do this. But we want to multiply this guy by 12. And I'll explain why it's by 12 in a moment, not 1,000 to get to kilograms. Or we should, we'll do doing that in a second. But it's because of this guy here. We want to times that 1 month by 12 to get the 12 months worth. Okay? We want to get this into 12 months, and then we can figure out the kilograms a bit later. So we have 300 grams times that by 12, and coincidentally, it's actually 3,600. So that's grams. And that's going to be per 12 months, or rather 1 year. So we're actually going to go back the other way this time, okay? Because we need to change what's actually going to happen in terms of the grams. So we've already got the 1 year. We already know that it's 3,600 grams for a year. We want to know kilograms, so we just need to change that unit of measurement. So we only need to do one side this time. And this time we're going to divide by 1,000 because 1,000 grams are in a kilogram. We divide 3,600 by that 1,000 and you should get to 3.6 kilograms for every 1 year. And you should get that for your answer. Our first example here in this part of this video is we are going to decide whether or not these graphs are in direct proportion or whether they are in inverse proportion or indirect proportion, and why or why not, depending on whether or not it is. So here's our first one. We've got A. It meets the criteria of being a straight line, but does not meet the criteria of going through the origin. So this one is not in either. So this is not either. Okay, because it's not going through or passing through the origin. That was one of the two main features of direct proportion, straight line going through the origin. If we look at B here, it is again not either one. So this one is not either as well. All right, it does go through the origin, but not a straight line. So it is not a straight line. So it doesn't meet that criteria, but it's also not inverse, despite it being one of those wonky ones, because it needs to go the other way. Okay, let's look at y now. Y, yes, it is a straight line. Yes, it goes through the origin. So this one is yes, direct proportion. And as I said, it goes through the origin and is a straight line. Our last one, no, it doesn't go through the origin. No, it's not a straight line. But yes, it is inverse. So it goes the other way. So this is yes to inverse proportion. Because as the x increases, the y decreases. All right, so that's how you can recognize these things. In play, we can look at this question. For a fixed price per litre, the cost C, so this is an important one to remember, the cost C of buying fuel is directly proportional to the number N of litres. So these are going to replace our X and Y. So remembering we have Y equals KX. This bad boy is going to become our X, and this guy is going to be our Y. So when we write the equation, instead of being Y equals KX, we're going to use C instead of Y. X is going to be N instead, and then instead of K, we're going to actually use that number that has been provided in our question. So Y equals KX becomes C, all right, because that's the cost. That's what we're looking for. This one is going to be directly proportional to 1.45 N, because that's what it's proportional to. Okay, and K obviously being 1.45, that being our constant rate of proportion. Then we can use our equation to then calculate the cost of 63 litres. So we go C equals 1.45 N. Well, we're going to replace the N because we know how many litres that is. And then we do all of our calculations. All right, so let's see our calculations happening. All right, there's our calculator. So we go 1.45 times 63 equals 91.35. So it'll be $91.35. Pop that calculator away again. All right, so that's how that's going to work there. Now we've got a couple more to look at. Now we're working with young Chloe. Chloe is earning money in direct proportion to the number of hours she works. All right, so we're going to look at finding K. So in this one, we're going to find K first. We want to find K. So to do that, we want to use our equation that we've seen before. We know what Y is going to be, because Y is going to be that wage, which is $166.50. And it's going to be K times k times 18. Alright. Now what we're going to do is we're going to divide both sides by 18. Because we're multiplying by 18, so we need to divide by 18. And that's actually going to give me k equals 166.50 over 18, and when I calculate all that out, I get $9.25. Now you are more than welcome to double check that maths on a calculator. What we're going to do now is we're going to use that value of k to rewrite our equation, a direct proportion equation. So W and the N are what we're going to use. That'll be Y and that'll be X, and obviously there's our K. There's our little K. So let's get our equation on. We know it's going to be a W at the start. We know the value of K now, that's 9.25. And then instead of X, we're going to use N. So it's just about the form of those equations. It doesn't always have to be X and Y. Whatever letters you use, it still needs to look like that though. Now I'm going to calculate the wages earned for 8 hours and 45 minutes of work. So I'm going to set up my equation. W equals 9.25N. I'm going to substitute in the value that I know, which is 8 hours and 45 minutes. Now 8 hours and 45 minutes, that is 8 3/4 hours, or 8.75. So just remembering that 45 minutes is 3/4 of an hour. So I'm going to have 9.25 times 8.75. Let's see that calculation in progress. Alright, so we're going to have 9.25. Alright, there's 9.25. Multiply that by 8.75. Hit my equals. And I've got there 80.9375. But I want to round off to 2 decimal places. So it's $80.94 because that 7's there. Okay, let's get rid of our calculator again. Alright, last one, we've got calculating the number of hours Chloe needs to work to earn $259. Again, I am going to set up my equation, substituting what I know, which this time is the W. Then I use some algebra, so I need to divide both sides by 9.25. Alright, and that's going to give me N equals 259 over 9.25. So let's see that calculation. Alright, so this is a division. So 2, 5, 9 divided by 9.25. Hit the equals and we get 28. 28 hours. All right. Now, they are all of our examples that we are going to do in this video. Hopefully they have given you some assistance, given you some interest in this, help you out with some of your questions out of your work. Good luck with those. If you have any issues, chuck them in the comments below, and see you in the next video.